Is to show you how to find the p-value associated with a f-value. As you know, f-test is the calculated ratio of two different variances. It's the first bullet point says there are two variances. We're just looking at the ratio of these two. The most common cases, we will put the larger variance on top and the smaller variance at the bottom. So doing that is associated with a right tail f-test, and it's also called the folded f-test. So you learn f-test in the following three situations. The first one is when we are conducting an independent sample t-test. Independent sample t-tests apply to two different groups of people or subjects. In this scenario, because they are two groups of very different entities, so we have to see whether these two groups have equal variances. So that's the first situation. Second situation is when we're doing the simple regression, and after we calculate the regression line, we need to do a significant test in terms of the quality of this simple regression line. And to calculate that, it's a ratio of the variance due to regression versus the variance due to error term. And this is just a simple comparison. We want to know whether the information, the signal coming out of the regression line is larger than the background noise due to error. In the third situation, that's in the ANOVA chapters, the ANOVA test is basically calculate the ratio of the variance between groups versus the variance within groups. So as you can see, in all three situations, you'll have two different variances from different sources, and you just need to calculate the ratio of that. That's basically how we created this f-test. These degrees of freedom is a very critical concept in f-test. F-test, because it's two variances and each variance has a degree of freedom. The degree of freedom 1 is the degree of freedom associated with the numerator. Remember, our f-test is a simple ratio. And when we do a ratio, it's a division. So we have a numerator and a denominator. And we have a degree of freedom associated with the numerator. And we also have a degree of freedom associated with the denominator, because they are two different groups. Okay, all right. What we are going to learn today is actually use Excel function to find the p-value, the probability associated with a calculated f-value. And we can also do it reverse. We can find the critical value of a folded f-test, which means you have set an alpha level, like alpha equal 0.05, and you need to know what that critical value of f is. So it's a known probability and trying to go back to find the f value. So these two are something I will show you how to do in Excel. So let's open up a blank Excel file. as we are talking about, let's do from a known f value, a calculated f. Let's do a calculated f value. We did a calculation and we found a calculated f, but we need to find the p-value associated with that f value. So let's see, we have f equal 1.86, and in this calculation we have degree of freedom 1 equal 12, and we have a degree of freedom 2 equal 14. Okay, so what it means is you have two different variants, and they are from two different groups. And the degree of freedom associated with group 1 is 12. The degree of freedom associated with group 2 is 14. That's just the numbers we come up with. Alright, so our job is, here is a calculated f. You need to find the p-value for this f. So we need to know whether this f test is significant or not. Because the decision rule based on p-value is very simple. If the p-value, the calculated p-value, is less than 0.05, then the result is significant. If the p-value is greater or equal 0.05, then the result is not significant. So using Excel will make it very convenient. You don't have to have a bunch of probability-based table in the back of the book. Okay, so as we show you the function, equal sign f. Okay, let's just capitalize it, f, distribution, and most likely we are dealing with a right tail distribution. Okay, in this situation, you see it provides you with all the necessary parameters here. X is your calculated f value, degree of freedom 1, and degree of freedom 2. As we were saying, the calculated f value is 1.86, comma, degree of freedom 1 is 12, degree of freedom 2 is 14. Okay, right parentheses, close the operation, and hit enter. Okay, you see Excel readily provides you with that p-value associated with your calculated f value. This p-value turned out to be 0.13379, which is greater than 0.05. So the result is not significant. Okay, so that's very simple process. And let's say we want to do the reverse. When we do the reverse, usually we say, okay, we have p-value, we have a known p-value, and we need to find the f value. Okay, so it's reversed. Known p-value to find the f value associated with that. And usually when we have a known p-value, we kind of have a set standard. Let's just try to find whether it's significant or not, and by using alpha equal 0.05. So we have a p-value 0.05, then let's go ahead and use the same degree of freedom. Degree of freedom 1, that way you can compare whether we use critical value or we use the p-value, we should get consistent result. Okay, so now we say what happened is we have a p-value equal 0.05 with degree of freedom 12 and 14. And what is that critical value of f associated with that p equal 0.05? Okay, equal sign. So Excel, you need to do operation. And f, because it's opposite from the way we did before. The first example we have calculated f is known, and we need to find p-value. Right now we have known p-value to find f value. So we have to do inverse, INV, and still we have the right tail. Okay. Alright, and the operation shows up as down below, tell you need probability, you need degree of freedoms. Alright, so probability, as we were talking about, 0.05, and degree of freedom 1 is 12, degree of freedom 2 is 14. Degree of freedom really depends on what kind of number you're working with. So all these just an example. You have to adjust to whatever the number you have. Okay, so inverse, right tail, p equal 0.05, 12, degree of freedom 1, and 14 is degree of freedom 2. Right parentheses, close the operation. We already hit enter. Okay, so the critical value of f is 2.53424. So our calculated f is only 1.82. So if you use critical value, this calculated f is less than the critical value of f. So the result is not significant. That's one way to look at it when you compare the critical value. If you compare the p-value, the calculated p-value for f equal 1.86 is 0.13379 compared to the set alpha value equal 0.05, that p-value is greater than 0.05. So the result is not significant. So either way, you have the same result, not significant. Alright, I hope this is clear, and go back to the PowerPoint slide and you can pause and you can look at the different, especially the Excel function here, and go through the process again on your own. Make sure you practice. Thank you for watching. Bye-bye.